Building a UGC team used to cost $10,000 a month minimum. You need to hire creators, manage campaigns, handle posting schedules, and pray your content actually converts. But here's the thing, I just built an entire AI UGC team that works 24/7, creates unlimited content, and posts across every platform automatically. Because the most successful marketers aren't hiring humans anymore. They're building AI agents that do everything a $10,000 team does, but for pennies on the dollar and without any of the headaches. Today, I'm gonna show you exactly how to build your own AI UGC team using vibe marketing principles with N8N. This system will research trending content in your niche, generate scripts using Claude's latest model, create hyper-realistic UGC videos with AI actors, and automatically post them across Instagram, TikTok, Facebook, YouTube, and LinkedIn, all while you sleep. By the end of this video, you'll have a complete AI agent that replaces an entire marketing team. No more hiring creators, no more managing campaigns, no more manual posting, just pure automation that generates customers on autopilot. The best part? This runs completely hands-off. You set it up once and it becomes your personal content factory, pumping out engaging UGC ads that actually convert. Let me show you exactly how to build it. I added the AI tools that we're gonna use in the description, so you can check them out. Before we dive into building, I want to show you exactly what this workflow looks like when it's up and running. Right at the start, you can see we've got a choice between a manual trigger, perfect for when I want to run it instantly, or a scheduled trigger, which takes care of everything automatically in the background. As soon as I hit execute workflow, you'll notice the flow begins lighting up node by node, so you can follow along with what's happening. Here you can see the green section. This is where all the research and script generation happens. Notice how the AI agent posted past scripts from Airtable first, just to make sure nothing gets repeated, and then instantly outputs a brand new script, caption, and description. If we jump over to Airtable at this moment, you'll see those fields populating in real time, which is incredibly satisfying to watch. From there, the workflow shifts into video production. Here you can see the script ID being sent to ArcAds, kicking off the rendering process. We'll give it a moment to process, and if I check my ArcAds account right now, there's the video being generated with the exact data from Airtable. Once it's ready, you can see the final step, automatic uploads to YouTube, TikTok, and other connected platforms, happening without me touching a thing. And just like that, the content is live across multiple platforms with zero manual work. From seeing it in action, you can already get a sense of how each part plays a role in getting from idea to published content. Now, let's break it down step by step so you can actually build this yourself. Alright, time for us to decide how the whole system will actually run. Sometimes you want to hit a button and make things happen instantly. Other times, it's better to let the system handle the timing for you. That's why this workflow starts with two different triggers, one for manual control and one for scheduled automation, so you can decide exactly how it runs. Let's start by adding the manual trigger. Then we'll bring in the schedule trigger. In the configuration, set the trigger interval to days and the days between triggers to 1, so it repeats daily. Then set the trigger hour to 8 AM, giving you a consistent posting window without having to think about it every morning. For the trigger at minute setting, we use a small JavaScript function to choose a random minute each day. If your base time is 9 o'clock AM, it might actually run at 9:06 one day or 9:13 the next. This slight variation helps keep the timing from feeling too predictable, creating a posting rhythm that looks natural. Now that we've decided when the workflow will run, we are now going to give the keys to the content vault. ArcAds is where all our AI-generated videos live, but until we connect the two, the workflow has no way of knowing where to find them. This is why we need the set field node. It acts like the passcode that opens the door and sets the system straight to the right folder. We'll start by dropping the set field node into the workflow and switching its mode to JSON. Now think of this JSON as a little envelope where we'll store two important pieces of information, the API key and the folder ID. To get the API key, open your ArcAds dashboard, go to the public API settings, hit Get New Credentials, and copy the code it gives you. Back in the workflow, paste that into the ArcAds_API_key field. Next, we need to tell the workflow exactly which folder of videos to grab from. Now log into ArcAds, open the folder you want, and take a look at the URL. Everything after the slash at the end is your folder ID. Copy that and paste it into the ArcAds folder ID field in the JSON. Alright, this set field node now works like a precise set of directions, giving the workflow instant access to the exact videos it needs to move forward. Connecting ArcAds was just the first step. Now we need to pull the actual data that the workflow will use. Now think of this as opening the door and letting the system walk in to collect exactly what it needs. In this case, that means fetching pro-level situations from ArcAds, so the next parts of the automation have high-quality content to work with. Let's add an HTTP request node to the workflow to handle the call to ArcAds and return the data we need. In the ArcAds API documentation, locate the HTTPS URL for the getSituation API and copy it. Back in the node, set the method to get and paste the URL into the field. Authentication won't be required for this request, but make sure to toggle send query parameters on so we can define exactly what the workflow should retrieve. The query parameters are simple but important. Page uses a JavaScript snippet to randomize the numbers so each request can return different results. Page size is set to 50 to get a full batch of content, and isPro is set to true to make sure only premium situations are included. Under send headers, toggle it on and add accept with the value application/JSON for clean formatting and authorization map from your stored ArcAds API key. There you go. Your workflow can now pull in fresh pro situations from ArcAds automatically, ready to be used in the rest of the build. When a workflow starts to grow, keeping track of what each node does becomes harder than it should be. That's why before moving forward, it's worth taking a moment to rename the HTTP request node from the last step. Giving it a clear, descriptive name means you don't have to dig through settings later just to remember its purpose. Our next move here is adding a split out node. This takes the batch of data we pulled from ArcAds and breaks it down into individual pieces, so the workflow can process each one separately. In the configuration, set fields to split out to the items field from the getProSituation step. Under include, choose no other fields to keep things focused only on what's needed. Now, instead of a single large block of data, you've got neatly separated items, ready for the workflow to handle one by one. If we always work with the same order of items, the content coming out of this workflow will start to feel predictable. To keep things fresh, we can shuffle the situation so each run has a different starting point. This not only adds variety, but also makes the workflow feel less repetitive over time. To do this, we are going to add a sort node to the workflow. In its configuration, set the type to random. This tells the node to mix up the order of the items instead of sorting them in a fixed pattern. So every time the workflow runs, the situations will be presented in a new randomized order, keeping your output dynamic and preventing it from looking automated or stale. After shuffling the list of situations, the workflow now has them in a random order. But we don't want to process them all at once. Instead, we'll focus on just one at a time. This will keep things organized, easier to manage, and ensures each situation gets processed fully before moving on to the next. To set this up, I'll add a limit node to the workflow. In the configuration, set max items to 1 so the workflow only keeps one situation at a time. Then set keep to first items, which makes it take the very first situation from the shuffled list. Because of that, the workflow will always grab just one situation, work through it completely, and then be ready for the next run, preventing overload and keeping the process smooth. At this point, the workflow knows which situation it's working with, but it still needs the voice that will bring that content to life. This step connects to ArcAds to pull in the exact voice details we'll use later, making sure the audio is ready before moving into the production phase. We are going to start by adding another HTTP request node to the workflow. In the Parameters tab, we need to paste the prepared script into the URL field. This script is used instead of copying the endpoint directly from ArcAds API documentation because it's more stable and less prone to breaking over time. Then, set the method to get, keep authentication as none, and turn send query parameters off. Then toggle send headers on, adding 2 headers. Accept with application/JSON to get a clean response format, and authorization map from the Arcad's API key stored in your Arcad's credentials. Next, head to the Settings tab. Switch SSL certificates off and keep always output data, execute once, and retry on fail all set to off. For on error, choose continue. This way, if the request fails, for example when an invalid ID is passed, the workflow won't stop running. This makes the process more resilient, allowing the rest of the automation to carry on even if one voice request doesn't return a result. Now that the workflow can fetch voice details, we need to make sure it only moves forward with usable results. That means 2 checks. First, confirming that a valid voice ID exists, and second, filtering out any voices with negative emotions we don't want in our final videos. These 2 safeguards prevent the workflow from producing incomplete or off-brand content. For the first check, add an if node to the workflow. Set the condition type to string, the rule to is not empty, and map value 1 to the ID field from the get voice details node. This ensures the workflow only continues if the ID is valid. If the result is empty, connect the false output back to the get pro situations HTTP request node, creating a loop that keeps trying until a valid ID is returned. Once that's in place, we'll now add the second if node to filter out unwanted emotions, connected to the true output of the first if node. Set the condition type to string, the rule to is not equal to, and map value 1 from the descriptive field from the get voice details node. Set value 2 to sad, then press add condition and add another rule with the same value 1 mapped, but value 2 set to frustrated. If either of those emotions is detected, connect the false output back to get pro situations so it loops until a positive match is found. Now the workflow only moves forward when it has a valid voice ID and an emotion that fits the tone of the video. To keep our content fresh, it's important to avoid repeating scripts we've already used. This step connects the workflow to Airtable so it can search through past scripts before creating new ones. By checking against existing content, we make sure every output is unique and relevant. We start by creating a personal access token in Airtable. In your Airtable account, open the token creation settings, give your token a name, and select the following scopes: data record read, data record write, and schema basis read. Click add all resources, choose the base that matches your use case, and then press create token. Copy the token that Airtable provides. Going back to N8N, open the Airtable credentials section and paste the token into your access token field for your Airtable account, then click save. Now add an Airtable node to your workflow. In the parameter section, set resource to record and operations to search. Select your base and table from the lists and switch return all to on so the node can retrieve all matching records. After that, the workflow can now look up previous scripts before generating a new one, helping you maintain variety in your content. Once the workflow can pull past scripts from Airtable, the next step is to organize them into a single, easy-to-read list. Instead of working with dozens of separate records, we'll combine them into one collection so the AI can process everything at once. This makes it much simpler to compare, filter, or reference old scripts when generating new ones. Before doing that, it's also a good idea to rename the previous node to something clear like get past scripts so it's easy to identify later in the workflow. To set this up, we are going to add an aggregate node to the workflow. In the configuration, we need to set aggregate to all item data into a single list and choose data as the field where the output will be stored. Under include, select specified fields so we can control exactly what's combined. From the renamed getPastScripts node, we'll map the created time, script, and caption fields. This keeps only the relevant information and avoids unnecessary data clutter. Having this in place lets us have a clean, consolidated list of past scripts ready for the AI to reference. helping it generate fresh, original content every time. At this stage, the workflow has all the reference material it needs. Now it's time to turn that into a brand new script. To make that happen, we'll guide an AI model with a carefully written prompt, define exactly how the output should be structured, and make sure it's generated by a tool that's capable of delivering detailed, context-aware results. I am going to start by adding an AI agent node to the workflow. For source for prompt user message, select define below, then paste in the prepared script for the prompt user message. Switch require specific output format to on and keep enable fallback model set to off. Add a new option and set the system message to the prepared script as well. This helps control the AI's tone and direction. Under the AI agent node, add an output parser and choose structured output parser. Let's set schema type to generate from JSON example and paste in the prepared JSON example. This will serve as a template, showing the AI exactly how to format its response so the next node can use it without issues. Lastly, we are going to configure the chat model. First, we need to create a new credential in your Anthropic account, then generate an API key, then paste it into n8n. Save it, then set the model to Claude Opus 4. We selected this for its strong research capabilities and reliability in producing clear, well-structured output. After the AI has generated a new script, we want to store it somewhere we can easily review, track, and manage later. This step sends the output straight into Airtable, creating a new record automatically so every result is logged without any manual copy-pasting. It also means you can see the changes happen in real time right inside your Airtable base. First, we're adding an Airtable create a record node to the workflow. Next, we need to set resource to record and operation to create. Then we are going to choose our base and table from the lists. We also need to remove any default values we don't need so the record stays clean and focused. From the AI agent node, let's map the script field to the script value, the caption field to the caption value, and the description field to the description value. Once the node is configured, let's run the workflow and check your Airtable base. You should see the new record appear instantly, ready for review or integration with other processes. Before we send the script details to ARCADS, it's helpful to mark this stage in the workflow visually so it's easy to identify later. Adding a note not only makes the workflow easier to read, but also helps break it into clear sections. In this case, we'll label it Research and Scripting so anyone looking at the workflow knows exactly what this part is for. What we're going to do here is click the note icon in the side panel and give it a title. If you include a hashtag before the title, it will display as a header in the workflow. Once that's in place, we can now add an HTTP request node. In the Parameters tab, let's paste the prepared script into the URL field. Set the method to post, leave authentication as none, and turn send query parameters off. Also, toggle send headers on and add 3 headers: accept with application/JSON, authorization from the prepared script, and content type with application/JSON. Next, toggle send body on, set body content type to JSON, and select specify body. Paste the prepared JSON script here. This is what tells the API exactly what data we're sending. Using the prepared script instead of copying the endpoint directly from the ARCADS API documentation ensures stability and reduces the chances of errors. Finally, check that the script runs without issues. With this step, the script ID is now being sent to ARCADS in a structured way, ready for the next part of the process. Everything so far has been about preparing the right script, structuring the data, and making sure ARCADS has what it needs. Now it's time for the payoff, which is sending a request that tells ARCADS to take that script and start producing the actual video. This is the point where the workflow shifts from setup to creation, turning all the earlier steps into something you can watch. To set this up, we need to add an HTTP request node to the workflow, and then open the Parameters tab. Paste the prepared script into the URL field, set the method to post, and keep authentication as none. Turn send query parameters off, then toggle send headers on. Add 2 headers: authorization from the prepared script and accept with the value application/JSON. After configuring the node, rename it so its purpose is immediately clear when scanning the workflow. Just like in earlier API calls, we're using a prepared script instead of the direct ARCADS API endpoint to make the process more stable and less error-prone. Once this step is complete, ARCADS will begin generating the video, bringing together all the previous work into a tangible output. The video's done, but right now it's just sitting in ARCADS. You can't use it until you have the link. This step is about reaching back to ARCADS and asking, "Where's my finished video?" Once we have that URL, the workflow can pass it anywhere. A storage folder, a publishing tool, or even directly into a social media scheduler. To make the request, let's drop in again an HTTP request node and head to the Parameters tab. Paste in the prepared script for the URL, set the method to post, and leave authentication set to none. No query parameters are needed here, so keep send query parameters off. Switch send headers on and add 2 headers. Accept set to application/JSON and authorization map from your ARCADS API key. Once you got that in place, rename the node to something clear so you'll instantly know what it's for when scanning the workflow. When this runs, ARCADS will return the direct link to the generated video, ready for whatever the next step in your automation might be. However, video generation doesn't always happen instantly. It can take time and sometimes it doesn't finish at all. Given that, we are going to build a smart loop that keeps checking for the finished video, waits when it's still processing, and stops gracefully if it takes too long. It's a safety net that ensures you either get your completed video or know exactly when it's failed. We'll start with the first if node, renamed so it's easy to spot. Set the condition type to string, the rule to is not empty, and map value 1 from the prepared script. If the video URL exists, the workflow jumps straight to the Airtable update record node to log the result. If it doesn't, we send it to a wait node. Configure the wait node to resume after time interval with a wait amount of 1.00 and minutes as the unit. Rename it so it's clear this is your video processing delay. Next comes the second if node, again renamed for clarity. This one checks how long the generation has been running. Set the condition type to number, the rule to is greater than, map value 1 from the prepared script, and set value 2 to 60. If the process has been running for over an hour, connect the true output to the Airtable update record node and update the record with final video failed to upload. If it's still under 60 minutes, connect the false output back to the get video URL node so it loops and checks again. With these 4 nodes working together, the workflow can wait patiently for a video, detect when it's ready, or stop the process if it's taking too long, all while keeping Airtable updated in real time. After all the processing, checks, and loops, this is the point where we lock the result into our records. The video is finished and now it needs to be written back to Airtable so there's a clear, permanent record of its creation. This is what turns a completed workflow run into documented progress you can track over time. Start by adding a node to mark this part of the process and name it as you like to visually break up the workflow. Then drop in an Airtable update record node. Set resource to record and operation to update. Then select your base and table. Map the ID from the prepared script so Airtable knows which row to update, and link the final video field to the prepared script containing the video's URL. Strip out any unnecessary fields so only the essential data is saved. This step is now executed here in the demo itself since it takes roughly 10 minutes to reach. But once it's active in your workflow, every completed video will be logged automatically. That means you'll always have a clean, up-to-date history of every piece of content the system produces. No manual updates required. As the workflow nears its final stages, it's a good time to clean up the data and make sure only the essential details move forward. Passing unnecessary fields into the next step can cause clutter or confusion, so this stage focuses on keeping the output lean and purposeful. To set this up, let's add a set node to the workflow and change the mode to manual mapping. This allows you to specify exactly which fields should continue through the process. Map the video description, the video title, and the video URL to their corresponding values from the prepared script, ensuring that each field is properly labeled and ready for the next step. This controlled mapping helps maintain a consistent data structure, which is especially important if the output will be used by other systems or integrated into automated publishing flows. Although this step is also not executed during the demo, since it takes about 10 minutes to reach, it plays a key role in the completed workflow. This acts as a final filter. It ensures that the next node only receives the clean, relevant information it needs, making the process smoother and reducing the risk of errors or unnecessary complexity further down the line. Now, to make sure the generated video can be uploaded and shared, the workflow needs to connect directly to Blotato. We are going to set up the necessary credentials so the automation can send media files straight to the platform without any manual intervention. After this, the connection will ensure that any content produced earlier in the workflow can be instantly transferred to Blotato for hosting, sharing, or further distribution. Let's begin by adding a Blotato upload media node to the workflow, then create new credentials for the connection. Visit your Blotato account to retrieve the required API key. Paste this API key into the credential field in N8N and click Save to store it securely. The workflow now has permission to communicate directly with Blotato's API. Next, let's configure the node by setting the resource to media and the operation to upload. For the media URL, map it from the prepared script so the system knows exactly which file to send. This integration ensures that as soon as the video is ready, it can be uploaded to Blotato automatically, removing the need for manual uploads and keeping the process fully streamlined. After sending the video to Blotato, the workflow shouldn't rush ahead. It needs to pause just long enough to make sure the upload has settled and the file is ready to go. This short break prevents the next step from trying to work with a video that's still processing, which could cause errors or incomplete results. It's essentially a built-in patience step that helps everything run more smoothly. Setting this up is simple. Drop a wait node into the workflow and configure it to resume after a specific time interval. In this case, it's set to 30 seconds, a quick pause that's usually enough for shorter videos. If you know your content runs longer or has more complex processing needs, you can increase this time so the workflow always resumes when the file is truly ready. Although this step is not executed during the demo due to the time it takes to reach, it's an important safeguard in the live run. We are introducing a deliberate pause to ensure that every action taken afterward is working with a complete, accessible file, keeping the entire automation reliable from start to finish. The video is done, processed, and ready to go. Now it's time for the big moment, publishing it to your audience. Instead of logging into platforms and manually uploading files, the workflow takes care of it automatically, posting directly to YouTube and TikTok the moment everything is ready. This isn't about just saving time, it's about hitting both platforms instantly while the content is fresh and momentum is high. To publish on YouTube, add a Blotato create post node and set the resource to post with the operation set to create. Choose YouTube as the platform and select your account from the list. Map the text, media URL, and video title from the prepared script. Set the privacy status to public, enable notified subscribers, and toggle made for kids to on. For TikTok, add another Blotato create post node with the same resource and operation settings, but choose TikTok as the platform. Select your account, map the text and media URL from the prepared script, set the privacy level to public to everyone, and rename both nodes so their purposes are clear. Make sure both of these upload nodes are connected to the wait node so they only run once the video is fully ready. This ensures your freshly generated content is published to both platforms without delay. The configuration can also be adjusted to suit different posting requirements, giving you flexibility while keeping the automation fully in control of distribution. Publishing the videos is only half the story. The other half is making sure you can always find them again. Here, we'll be needing Airtable. We need to save the exact post IDs from YouTube and TikTok to build a complete record of every video your workflow has ever released. It's like giving each one a tracking number so you can pull it up instantly, check performance, performance or reuse it for future campaigns. To keep YouTube in sync, add an Airtable update record node right after the YouTube upload step. Point it to your base and table, match records by ID, and then drop in the video's own ID along with a YouTube post ID from the prepared script. Do the same for TikTok. Add another update record node, configure it to match an ID, and map the TikTok post ID. Renaming these nodes so their rows are obvious will save you a ton of time if you ever revisit this workflow later. Here in our walkthrough, prepared scripts stood in for the real-time data because it takes about 10 minutes to reach this point. But in an active workflow, we can pull those IDs straight from the upload nodes themselves. The moment your videos hit each platform, Airtable gets updated automatically, leaving you with a live, always accurate catalog of every piece of content you've ever published. And that's it. You've just built an AI-powered UGC team from the ground up. No wasted time, no bottlenecks, no expensive human team to manage. Just a fully autonomous content engine running on its own. It's wild to think that this level of automation used to cost brands tens of thousands every month, and now you can set it up yourself with the exact same power for the fraction of the cost. What you have now is more than just a workflow. It's a complete marketing machine that never sleeps, never misses a deadline, and never stops creating. And if you're ready to take this even further, hit that subscribe button, drop a comment with a niche you're building for, and check the links in the description to grab all the tools I used in this build. Your AI marketing team is waiting. Now it's time to put it to work.